Okay, so now we're going to look at 5.6, analyzing logarithmic functions. So what it is your calculator works only on logs in two bases, base 10 and base e, which is an irrational number and it's approximately 2.7. We call it natural logs, right? So log is just a regular logarithm with base 10, and the button that says ln is a natural log with base 2.7. Base 10 logs are also called common logs, right? I should say that in the last lesson. And base e logs are called natural logs. So what we can do is we can use a calculator to find exact values of logs, and if not, to the nearest thousands we'll look at. Okay, so log of 1,000. So plug it in, it equals 3. And if you want to look backwards, you can go, oh, yeah. 10 to the 3 equals 1,000. That works. So then log of 45 is 1.653, right? That's something you wouldn't be able to calculate on your own without a calculator. So 10 to the 1.653 would equal 45. Natural log 3, when you hit that, is 1.009. So our base 2.7 to the 1.099 will give us our 3. Well, what happens is sometimes you're going to get logs like this, log 620. Well, the problem is you can't calculate that in because you can't put it in your calculator because normal logs are base 10. Well, what you can do is you can use something called the change of base. And what that does is it takes a log and changes it into something that you can calculate, and it changes it to a base of 10. So look clear, you got log b of x. Well, here's the pattern. If you see the x, the one at the end, that one goes to the top. So it's going to be log a of whatever's on the top there. And then the b part goes to the bottom, right? So there's an example on the next page. I'll show you that. So the next part is a proof. We don't need to worry about that. All you got to realize is change of base. The farthest part goes to the top. The b part goes to the bottom. All right, flip page and let's look at this first example here. So evaluate log 6 of 20 to the nearest 10,000. Well, now you can actually do it. So here's the deal. Log 6 of 20. The 20 goes to the top, so log 20. Now, if you notice there's nothing behind that log there, well, that's base 10. That's unwritten there, okay? And the 6 goes to the bottom. So you can plug that into your calculator. You can get your decimals here, and they're going to round to the nearest 10,000. So then we round it like that. So this allows you to do logs with different bases. This is 5.3 from your notes. This is kind of interesting. This allows you to calculate stuff. So when we did 5.3, it was a interest question, and we ended up getting this part, 2 equals 1.05 to the t. And at that stage, you weren't able to actually calculate it. Well, now you can because you can use change of base. So what we do is we take this one here and change it to logarithm. So t equals log 1.05 to the 2. Hey, do change of base. The 2 goes to the top, the log of 1.05 goes to the bottom. And when we do the calculations, you can find that it was 14.2 years, whatever the interest was. I don't remember the question. Okay, last page, example number 3. What we're going to do here, we're going to use the parent function to sketch the graph of y equals negative log 2, x minus 1, and then plus 1. And when we're talking about parent function, we're talking about what an original log looks like. So if you look here, you see that it's a 2. So the original function is log 2. So if you look, here it is here. Now, what if you didn't remember that that's what a log 2 looks like? Well, can you do y equals 2 to the x? Do you remember the exponential one that comes up through this one? Yeah, you can do that. Then you draw your y equals x line in and flip it over that. But if you can remember what y equals log 2 looks like, then you're good to go. So a couple of key points here. 1, 0, 2, 1. Those are key things. All right. So what we can do is we can do all the changes to this. And you got to remember the order that you do stuff in. Well, we got to deal with this negative first. Oh, yeah, right? We got to deal with reflections and transformations before we do. That's a horizontal translation, and that's a vertical translation. Okay, so let's deal with this one. So what we're going to do is we're going to flip that one. So that's going to create us right there. You can see it. Y equals negative log 2 to the x. Everything just flips. Okay, then we can do, it's either one we can do. Let's do the inside one. We're going to move it left and right, horizontal translation. So horizontal translation on this one is, hey, what do we plug in there to make that equal to 0? Yeah, 1. So it's going to take the whole thing, the red one here, and transfer it 1 to the right. So you can move your points, easy peasy. Then we have the plus 1. That is going to be a vertical translation of up 1. So the green one, everything gets shifted up 1 to create the purple one. So what we've done is we've taken the original parent function and then did all this stuff to it. Now, what if you didn't know how to do that? Well, come down here. You can look at the new one. Well, this is what we just talked about. All the different things that happen to it. And let's say you're still struggling with it and still struggling with this. Well, what you can do is you can create a table of values based on what we do. So what you do is you look at your original table of values. And this is the original log here, right? Log 2. So a quarter, -2, a half, -1, 1, 0. Okay, and then what we can do is all this stuff here will create our new points. So think about what happens here. This negative in front affects the y value, and this +1 affects the y value. Okay, so then we do the y value, go down to the bottom here. Oh yeah, we make it negative, and then we add 1. Okay, look at the x value. What happens in the x value here is we're looking at this one here, and it's x -1. So what number do we plug in there to make that equal to 0? A positive one. So it takes the x value and adds 1 to it. So if you have a quick little table of values on the side here, all you have to do is take the x value of a quarter. Okay, quarter plus 1, 1 1/4. Easy. Take the y value of -2. That becomes -y, which it turns out to be +2, plus 1 is 3. And you can create a whole new set of values, and then you can graph those on the page. So there's 2 ways of doing this, like I said. You could do the parent function and then do all the transformations and translations to it. Or you can actually just create a table of values like we have at the bottom here. Either way works. Okay, so that's 5.6.